In the last video, we looked at the very common reaction of amines as bases with acids, such as HCl, to yield conjugate acid and conjugate base products. In this video, we are going to talk about how we name those products of acid-base reactions with amines. So in other words, how do we name these types of structures where rather than having a neutral nitrogen of an amine, instead we have a nitrogen that has a positive formal charge because it's picked up an extra proton. These molecules are referred to as ammonium salts. Salts because of the fact that they have a positive and negative charge, ammonium where the IUM denotes that the nitrogen has a positive formal charge. By the end of this video, we will be comfortable with naming these molecules using the IUPAC system. When we look at an ammonium salt, generally we are reacting an amine, such as this, with an acid, such as HCl. Remember from our last video that the nitrogen uses its lone pair of electrons to come over, grab a proton from the acid that forces the bond between the proton and chlorine in this case to break, giving as a product the chloride anion as the conjugate base and the protonated amine, or the ammonium salt in other words, as the conjugate acid. Now keeping in mind that the anion and cation are inseparable due to their opposite and equal charges, we're going to name these as a single unit. So the ammonium salt will refer to the entirety of what's on the product side of the equation, both the conjugate acid and the conjugate base, since those are inseparable. When we name ammonium salts, we're going to use the exact same rules that we used a couple of videos back for naming amines. But rather than the parent name being amine, the parent name is instead going to be ammonium. So we can look at the reaction that was used to create these molecules if we wanted, name the amine that was the starting material, and then just change the parent name from amine to ammonium, and we would be in good shape. Then we tag at the end of the name of the anion that is associated with the molecule, such as chloride, hydroxide, or whatever the case might be. So taking a look at the structures that we have here, we have our protonated amine and we have our chloride anion. And so in naming this molecule, to go ahead and take care of the perhaps easy part first, I'm just going to plug the term chloride on, because that is referring to the fact that we have that chlorine atom, and when it's a negatively charged chlorine, we refer to it as a chloride. So when you see the term chloride, know that that implies that there's a negative charge, much like bromide implies a negative charge. Now naming this particular structure here, remember that when we were naming amines, we found the longer carbon chain of the carbon chains that are attached here. So this carbon chain is a total of 1, 2, 3 carbons in our longest carbon chain. Here is 4. And so therefore, our parent name for this molecule is going to be based on the carbon chain over here. So it's going to be based on this carbon chain that I have highlighted out here. Coming up with the name for that will represent the parent name of the molecule, which we have at position number 1 of our longest carbon chain. We have our amine group there. So we do this 1, 2, 3, 4. So butan 1 amine would be the name if it didn't have that extra proton, but it's butan 1 ammonium since it has that positive formal charge, or 1-butan ammonium as a synonym for that. And then from there, to determine the rest of the name, remember that we use for secondary amines the prefix N to represent the other group that is bonded to the nitrogen. So here we have a 4-carbon group with a branch here at the next to last carbon of the chain that is referred to as an iso branch. This is an isobutyl group. So I would refer to this as N to denote that the isobutyl group is directly bonded to the nitrogen. And this isobutyl and butane, there really shouldn't be a space between these two. So let's take a look at this other example problem here. In this example problem, we have a primary amine with a 3-carbon chain, and we are bonded, or we have an anion of hydroxide. So naming first the hydroxide part, which will be the very last part of the name. I'm going to write that on there because we have a negatively charged OH group. That's referred to as hydroxide. Now naming this molecule here, we have our 3-carbon chain attached to our amine group, and it's at carbon number 1 where the amine is attached. So we would refer to this as propan-1-amine if it was a standard amine, but since it's protonated, it's propan-1-ammonium. So I'm going to go ahead and put propan-1-ammonium. And then there is a space between ammonium and hydroxide. The other term that you could use to describe this would be 1-propan-ammonium would work as well. And then space, and then the term hydroxide.